In this solution, I have a project which contains a database. This database is a expenses database, and in this database we have 3 tables. The tables bill is actually the main table, if I can say so. I mean, this is something that is the table that contains all the bills entering in which are going to be paid. The other 2 tables, this payment type and type of expenses, is related to bill table. Payment applied, the field payment applied in the bill table, is going to contain the ID of payment type. So each bill has associated the payment type. Similarly, there's also the type of expenses. Type of expenses is referred by the bill table in expense type fields. So expense type field is going to have contain the ID of type of expenses, but the ID here is referring to expenses type. So what we have actually a relationship to one-to-many. So we will have 2 relationship of one-to-many. So we have many bills that refer to one ID, to only one ID. We will have many bills that is referring to one type of payment, so a payment type. At the same way, we have also many bills that refer to only one type of expenses. So we will have one type of expenses and many records of bills. The same for payment type. Okay, here we have the diagram of these 3 tables, and we have the entity framework diagram in Visual Studio, and yes, there is missing the payment type table. Actually, the table is present, but the ADMX file doesn't show it. This is a feature of Visual Studio and this designer, that when there is some navigation properties that put in relationship one table with another, under some criteria, the table that is related to one another table is going to be hidden, but is present. So to understand what created this relationship, I created another project, which is on the other screen here, virtual screen, and we see that there are all the 3 tables without any relationship among them, and we are going now to create this relationship. Okay, before proceeding in creating the relationship among these 3 tables, I would like to, anyway, to see how we create this, how we put these tables in the designer, which is not maybe is not so intuitive process. I mean, we have to go. Is not actually when we have the database, which is here. I'll show this one. This is the database where is containing all the tables, and in this Server Explorer pane we have the structure of this database and the tables related inside it. So how do we put this table in the designer? The first thing that one maybe is one can do, or say, is to drag and drop. So as you can see, if you try to drag and drop the table in the designer, this doesn't work. The designer doesn't allow us to drag and drop one table from the Server Explorer to the design itself. So in order to do that, we delete this one, all the tables, yes. Remove, we don't delete, we remove from the designer. So and now we just right click here on the empty space of the designer, and we go to the update model from database. This is the feature that allows us to include these tables in the designer. Okay, we click here. Now we click here, and we see that there is another three tabs here, but the one that we are going to choose is the add. The first one we have to, because we have to add tables. So we can choose, we can just add one, or we add everyone, all these tables. We have also the chance to add views in case we had, and start a procedure and function if we have. In this case we don't, so we can't. That's one is easy to understand. So there is another one here, some options. Okay, this option, pluralize or singularize generated object names. Actually, when we create the model and we refer to the database table, so we have many entries in the table. So this in this case, the system Visual Studio pluralize for us the relative reference name. So if we have, for example, in this case we have Bill, as we can see here, when we are going to refer in the code to the data set and all the elements inside Bill, Visual Studio will pluralize for us in Bills. So we know that when just by the name, we know that we are going to refer to plural, not just to the database, to the table as a structure, as a model, but to the table itself as its content of the table. So this is actually I keep this check selected, and because it's it's a convention that's useful to keep it on. We include all foreign key columns in the model, yes, of course. And now we're going to click finish, and this is the situation we had at the beginning. Now I let Visual Studio not showing some notice messages that are coming up as model window here that is going to warning us that we are modifying the structure, and there is then two buttons to allow this modification or to reject it, but yes or cancel. But this one is quite annoying. Visual Studio is going to ask this question quite frequently, so I choose the option to not showing these messages again. So now it's not showing, but when you are going to do for the first time, you probably will have many of these, a number of these messages that are coming up, popping up from Visual Studio. Okay, now the next step is to finally create this the relationship among these tables, and then go on. So to create a relationship between two tables, in entity framework ADMX file diagram, we have to right click in an empty space and select add new association. In association, we give the name of this association, which is not so determinant. Then we have to fix and tell to the system what kind of relationship we want between which tables. So we have first to establish and select what is the table, the main table. Let's start with the main table, which is now is a payment type. Why is main table this one? Because payment type will have one ID of payment type is going to be present in many records of bill. So we here doesn't matter which one is we fix first, if a payment type here and bill on the other pane here in the other side, or vice versa. But what is actually important is to fix the relationship between these two tables. So here in the multiplicity we have the choices to select which one is the relationship between the two. So here we have payment type, which is one payment type, is present in many records of bill. So this one is the correct one. Then we have to fix this navigation property. I like to do in this way. So it's nav bills from payment type. So this navigation property, by the name of this navigation property, I can understand how I get what is the direction of this navigation property. So the direction is from payment type. I'm going to access all the bills that is the records that is present in the bills table, which have this payment type selected. So if I have payment type, for example, if the ID of payment type 1, I will have many bills, records in bills, having as a foreign key the payment type ID 1. I don't select this add foreign key for property in the bill because I already fixed, and when I designed the tables, I already foreseen the foreign key in a bill table. So here we got the foreign key, this foreign, which is going to contain the ID of payment type, is payment plight. So payment plight is going to contain the ID of payment type. So now I have to also to fix here the navigation property name for this for the bill. So it's nav payment type from bills. So even now I understand that I have, by the name I understand that I have many bills that is going to have one ID in payment type. Once I establish that, I click OK, and I created this the relationship between the two tables. Now there is another thing to do. Okay, now we said that there is a relationship, one to many, from one payment type as many bills containing the ID of payment type. So we have to tell to the system which one is the ID from payment type, and what is the field in a bill that is going to contain the foreign key in payment type. So let's see here the principle. So we tell here that it's payment type, because this one is what we saw before, is payment type. So the dependent one is bill. Okay. So the principal key is ID. Okay, and then we have to define what is the field that in bill that is going to contain the ID of payment type. This one is a payment applied, and this so we click OK, and now we establish the relationship between the bill and payment type tables. In the same way as before, we are going to create this relationship now from the two tables, bills and type of expense. We do exactly the same thing as we did before. So in type of expense, we know that we have just one type of expense, many records in bills that contains the foreign key of type of expense. So we do the same thing. The navigation property here also is the nav bills from type of expense. Here also the nav type of expense from bills. If you want to check what we have done, the relationship we have created is correct, we read what is written here in this dialog area. So here we have type of expense can have many instances built. That one is okay. Use type of expense nav bills from type of expense to access the bill instances. Okay, so bills can have one instance of type of expense. Use bill nav type of expense from bills to access type of expense instance. So what we create here is actually what we want. So we hit OK, and here too we have the relationship created, and now we have to tell what is the fields that are involved in this relationship. So is the ID of type of expenses, the table, which is principal, is the ID, and the foreign key in bill is expense type. We hit OK, and now the relationship is actually ready to use. I mean, all the three tables are now related in the way we want it. So we do OK here. We click close. So now we are ready to continue with the application and see how we use all this relationship, and we are going to use the link to access the tables in the relationship we just created. So at a certain point, for some reason, Visual Studio and the identity framework model diagram converts this relationship and this actually drawing here, this design here, to this version. So it simplifies. See, now it simplifies by hiding a table. In this case, the table that is hidden is the payment type, but it's still present. It's not that it's disappeared. It's still present on the diagram and then on the entity framework project. So we see here in the model browser, we see that we have actually the table. Here it is. See now, this is the bill, and so it is actually only the visual aspect that is missing the table, but everything is still working and as it should. Once we finish with Model Designer, we are going to see the LINQ code that we are going to implement in order to retrieve the data from the database. We have here three different versions and even different approaches which is going to achieve the same results, but in different ways. So the first thing we are going to see is this. Oh, by the way, here the code we are going to see here is the LINQ syntax. It's not the extension method. All of this, actually there are three versions, and all the three versions is using the extension, not the extension method, but the LINQ syntax. So we are going to see immediately what is the first one and how it works. We have two from statement, and the first one is the from X in expenses entities type of expenses. So in X member we are going to retrieve the type of expenses table. So actually the X member is going to point to this table here. Similarly, in the second from statement, we are going to actually use the X member and access the bill table through the navigation properties. The navigation properties, as we saw before, this navigation property nav builds underscore from underscore type of expenses belongs to the type of expenses table. So this navigation property has been defined inside the type of expenses table. Through this navigation property, we are going to access the members in the bills table. So what we are going to have here is actually we have all the type, which is the source, right? All the type of all the records of the type of expenses, and through the index of the type of expenses table, we are going to access all the records inside the bill table, which have the same with a relative ID of type of expense. Once we have this, we are going to create an anonymous type we are going to define this anonymous type in the select statement. As we can see here, we have a select. We can see here, we can do in that way. Yeah. Okay. So here we have a select new, and we define an anonymous type with a number of properties, and these properties are amounts, and we define inside. So it's not actually this type has been defined on the fly. So this is actually anonymous type because there is no reference in the code for this type here, and we just created inside the LINQ statement. So select statement in this case. So here we have amount. So we have defined amount, date of bill, archived on, expense type, and payment. So to this properties, we are going to associate the relative properties of the database involved. So here we have a Y amount. So Y, we know that Y is containing the bill records, right? So here we are going to take the amount of the bill, the date of bill, yeah, archived on, yes, always on bill. You see here, so the IntelliSense here is going to put in evidence that Y is actually a bill type, right? It's a bill reference to that table. So then we have to retrieve the payment. The payment is not inside the bill table. So his payment is the payment type, and belongs to another table, which is type of payment. So here we have Y, which is bill, we know already. So this is this one is the navigation property inside the bill design. Yeah, well, before when we have defined the entity, the payment type table, we need to retrieve the type of payment, which is actually a string. Okay, so once we have all this anonymous type, we need to convert to JSON, and so we can send back to the client, which was performing the query, the request. So we are going to reply to response to this request through a JSON type. After we analyze this, we are going to see how everything is working through Fiddler. So we open Fiddler now, and we are going to now it's there. Okay, I just see that it's already working, so it's not. But now we are going to generate the query to a get request to the server, to the application, and see what the application reply. So we do that. We do an execute. We have 200, the code 200 as a response, so that means that everything has gone okay, everything is correct. We see what we have back, and we realize that we have actually the JSON format of the query. So this is the application of this actually methodology, using the entity framework and link to the entity framework. So here we have as we saw, we have the navigation property. We accessed all the data through the navigation properties, and now we are going to see another way how to do the same thing, but with a slightly different methodology and actually another approach, right? So now we comment this one, we leave this available because we need the return type, and we remove the comment on the other one. So let's see how it's working. This one a little bit, as you can see, a little more complex probably. Okay, sorry, this is not what I wanted. This one is okay. Yeah. So here what we have. So actually we have always the by the way, this one also is as I said before, this one is all these free example are using the LINQ syntax. It's not using the LINQ extension methods. So here again we have the syntax. It's clear that we have the syntax here. So we have three lines, three statements, from statements. So it's we see now it's a from X, like it's a little bit like before. This one is expensive. We are going to access the type of expenses, which is actually the source for this query, the source table. So the X is going to point to this table here, type of expenses. Y also is going to point to bill like before. So even here, Y is pointing to the bill table. And now we have another from statement here. And this one is going to access the payment types. So also we are not going to use all the navigation property here, but we are going to use the actually the IDs, the ID that are involved among the tables. So here we see that ZID is actually equals to Y payment applied. So Y is the bill, okay, is pointing to the bill table. We know that in the fields payment applied is going to contain the ID of the payment we applied. So it's here is an integer, and Z is actually the payment is actually pointing to the payment types. So we are going to put in relationship in equality and check that the ID is equal to payment applied. Here too we are going to then we created an anonymous type in the select statement. As you see, is a bit like before. So here we have amounts and weight of amounts, and like a bit like before actually. And we have also here the type of payment, and so this one is what actually is going to retrieve for us. So now we build this solution here. I think that everything is okay now, and we go to fill and we do the same. We execute the statement and we see what happened. Okay, now it's a seed also. You see, double click, and we see also here that we have exactly the same results as before, but we achieved this result through another approach. So maybe the other one is a little more, the one we saw before is a little more elegant and actually even less verbose than this one. This one is more articulate. Probably we have a bit more control on the code because we can associate the ID to the external key. So we actually, yes, but it's not big deal. Once we have to retrieve table through a relationship among them, is there is nothing that we can play much. The third and last approach we are going to study uses the most articulated design when compared to the others too. For this purpose, we created before a class which is going to contain some properties that we need to retrieve from the database. This class has been defined before. This is called, this one is called myObject, and this class contains 3 properties. And the first property is bill. So this is a property that's going to contain all the bill records. Actually, so all the fields contained in the bill records. Then we define the 2 other properties, or string types, which is going to contain the name of the relative expenses and the name of the payment applied. These 2, as we can see later, these 2 last 2 properties are going to be retrieved through the LINQ syntax, and we are going to see just now. So let's see this LINQ statements we are going to execute, and then in order to retrieve all the data that we need, that we use later on the application. So the first one is so we start with a from statement, and we have this range variable that is going to contain all bills, and then we have 2 join statements, and one is on the range variable spec is going to contain all the fields of the records which is retrieved by the ID which is defined in the bill foreign key. So in other words, what this statement is going to do is to retrieve the type of expense, just one record, which has the same ID which is defined inside the expense type field, which is defined in the bill table. So each record, is going to be scanned, right, from this when we executed this LINQ statements here, this LINQ expression, and or each of this when it's all, we scan all the bills, right, and then we see we are going to retrieve all the type of expenses records, just the record that is defined inside the expense ID. So I think that is quite easy to understand, right? I mean, it's when we see this this statement is actually intuitive to understand what is going on here. The same thing is applied to the other join statement here, and but instead of type of expenses is going to retrieve the same thing from the table payment type. So when we have all this, so we have all the bills, right? So we have all the bills, which is defined in the bill table. Then for each bill record, we are going to retrieve the relative records of type of expenses and payment type according to the ID defined on each foreign key. All this is are going to be then stored inside this through the an anonymous type here. So we have a bill B, which is actually a reflection of what is defined here in this anonymous type is the reflection of our object here. This is my object, right? So if you can see here, it's my object, it's a bill and the relative expense and payment applied. And when we go down here, we see here we have the same types defined on the object before. Okay. So when we then created this anonymous type is going to be contained inside a variable, this variable here, and then we define another a collection of list of my object, which are called M object lists. And when we define this list, we are going to actually to execute a loop through a for each, and scanning and retrieve and retrieve all the elements which are being contained inside the A variable, this variable here. So as we can see from this for each loop here, loop block, so we define a new object. So my object is which is another from M object. Then we actually associate with each element in the loop. For bill, so it's my bill, is bill. Here's all bills, right? Here is we are going to retrieve the string for relative expenses, and here we are going to retrieve the string for a payment applied. All when we have everything is filled in properly. Sorry, we are going to add to the list just created before. Once the loop has finished, we actually go through with the JSON object to the client. This is what's yes, there is another thing, it's an important thing to do, since this is not actually a good design, I would say. I mean, it's not elegant either. It works, but it's a little more yes, complex, and the complexity is also reflected not just to the code but also to the configuration of the entity framework, because we have to modify the configuration here, and we have to activate this statement which was commented before, and remove this comment here. What this statement is doing, now you see clearly here, is actually removing the lazy loading of the entity framework, which is enabled by default. So what happened here is actually that when the entity framework is going to execute a LINQ statement or a query statement, it actually used the lazy loading technique, approach. Actually, this is somewhat, I mean, it's reduce the traffic. I mean, reduce the throughput, which is going to when we are going to query the database, because when we with a lazy loading, where the entity framework before is collects all the queries and all the statements that are going to be executed in order to retrieve the data, and then it issues all these statement, all these SQL commands. Okay, is in this case is LINQ commands, but we know that LINQ command is then translated to a SQL command, right? So all these commands are going to issued to the database in one go. There must be something that is good and is bad for this approach. The good thing is there is less throughput, because it's when you collect all the statements to be issued to as a query to the database, you don't have to send through the network and through the internet all the requests, right? But there is also the risk of an overload of the database. So this one is maybe it's not the right thing to use when you have very complex queries to issue to the database, because finally the database could have some problem of overload, and with the performance issues is can happen. So but in this case we have to disable these lazy loading features, and so this is which is actually is not usually is not used, this statement here, meaning that we don't have to disable the lazy loading enabled. Before we didn't use it, this statement. Now we need, because otherwise we are going to have an error. So a long discussion. Now we are going to build the application, and we see now that this should be completed, right? Now it should be okay. So now we are going to take Friedla, which for some reason, yes, no, not now. So okay, now to the composer we take the last statement, and then we issue this request. Yeah, here now it's successful. We are going to check what happened. We have much more information than before, because we actually retrieved all the bill records. So we also with information that we didn't need. For example, you see now you have a expense type, which is the foreign key for the expenses. Now you have also payment applied, also that is contains the foreign key for the payment applied. So this is not actually useful. It's okay if it is there, but it's not useful for us for the purpose of our application. But what we have here is also the name of the payment and the relative expenses, like before, as we saw in the other examples. But in this one actually the work we had to do is a little bit more, and a little bit more articulated code. With this last one analysis study, I can say that I finished this discussion on retrieving multiple data from multiple tables through Entity Framework and LINQ. Thank you for watching this video, and see you next time.